Lipids. We are all familiar with lipids. We call them fat. How many times have you went through that drive-through and ordered a large order of French fries that have been deep fried in that oil, and they taste so good on your tongue and so salty while you're driving down the road hoping you don't cause an accident while you're having basically a heart attack in the waiting? Or how many times have you bit into that nice juicy hamburger with all of that grease dripping down your chin and you get it all over your clothes while you're trying to go to work? These are the worlds of lipids. They taste so good and they seem so good for me, but they are so bad health-wise. And we're going to look at this family of lipids because this family is quite diverse. But at the same time, we also hear these things about good fat and bad fat. So when Paula Deen takes that stick of butter and throws it into the skillet and fries up a nice ham sandwich that has been deep fried and breaded as well, is that really bad for us? And if so, why is it bad? Or some of the questions that you might have would be, I've heard this thing about butter. Should I be cooking with butter or should I be cooking with hydrogenated vegetable oil known as margarine? Which one is actually better for me? Should I be using olive oil instead of vegetable oil? Is there really a difference? This is what this module is going to focus on. However, we need to let you know that this is not a nutrition class. We're going to be looking at lipids, what classify things as lipids, and then we will kind of sprinkle that with some general use and general knowledge as far as nutrition and as far as health goes as well. Okay, so what are some of the things that I need to know about lipids? What are some of these kind of initial physical traits that we need to talk about? And the very first one is that lipids are found in all living organisms. So if it breathes, if it eats, if it sneezes, it's going to have lipids that are involved. Now, these lipids can be good and these lipids can be bad. So we're going to talk about these lipids again. We're going to look at the structures of these lipids and what classifies it as a good lipid and what classifies it as a bad lipid. One of the things that you have to take away is that number one, lipids are soluble in nonpolar organic solvents. Now, what that basically means is that lipids are nonpolar in nature. They are organic in nature. Hence, when you take oil and water and you mix them together, you get separate layers. And that's one of the reasons that that's happening, because water's polar and our vegetable oil or the oil that we're using is nonpolar, and you begin to see a separation layer that takes place. Lipids have many structures and lipids have many functions. And this is what's problematic about the family of lipids. If you go back and take a look at the lecture module concerning carbohydrates, we kind of pinpointed what made a carbohydrate. We said that these carbohydrates basically have an OH group, and these carbohydrates have aldehyde and ketone groups that we called aldoses and ketoses at that time. And we said this is what defines a carbohydrate. And if it has these functional groups, then this is what makes a carbohydrate, and we were very clear with our definition. We did the same thing with amino acids. With the amino acid module, we said amino is NH3 group, acid is COOH group, and that's physiological pH. And as long as it has those two groups, we're going to call it an amino acid if it fits our template. The problem with lipids is that there's really no template. You're actually going to see that in the next slide when I give you some examples of lipids, but they're all over the place. And this is what causes us some problems sometimes when it concerns, is this a lipid or is this not a lipid? You're going to find out that it's really not based on functional groups or a certain type of functional group. It's going to be based on physical properties instead. So these physical properties, they have something in common. What are those things that they have in common? We'll talk about that in the next slide. But we are not looking at functional groups here. There's no really common functional group for any of them across the board. It's very broad. So without further ado, let's take a look at some of these structures that we're going to be looking at throughout this lecture module. As you can see, there's really no common functional group throughout the structures that are listed on the slide. You know, if we take a look at this fat that's down here at the bottom, this is an ester group, a C double bond OO with a long hydrocarbon tail associated with it. And we have one here, and we have one there, and we have one here. So this is going to give rise to hydrocarbon. We see quite a bit of hydrogen and quite a bit of carbon, and we see a little sprinkling of nitrogen and oxygens and maybe some phosphorus throughout these molecules. But if I take a look at that molecule as a whole, I know that that is organic in nature, that is nonpolar in nature. So this basically is not going to dissolve in water. It's not going to associate itself with a polar environment. And because of that, it has a very high, significant hydrocarbon composition. And it is very hydrophobic, which means hydro water, phobic, afraid of. So this is afraid of water. You need to kind of be careful with it. Don't throw it into the river because it can't swim. So we're going to have to take baby steps when it concerns lipids if we want them to be in a polar environment. We'll take a look and compare that at some of these other lipids that are basically up here at the top. Well, this limonene doesn't really have anything in common as the fat down below. We see a ring structure. We see some double bond characteristic, but that's it. There's no long hydrocarbon tails. There's no ester groups. There really isn't even a functional group in limonene. However, limonene is an alkene. It does have some double bond characteristics. And limonene is not like a fat. Limonene, if you extracted that from an orange peel or a lemon peel, would smell very citrusy, but it will be oily in nature. It doesn't really like to hang out with water. So this is where some of your essential oils will come from, like the clove oil maybe that you distilled in one of our classes, or maybe some of you decided to distill limonene from a grapefruit or an orange during that time. And if so, you will see that these are oil droplets that formed at the top of that aqueous layer. And then let's take a look at some of these other lipids, like vitamin A. We see some conjugated double bond systems in the structure. We see some double bonds that are alkenes, just like limonene is. But we see kind of this long hydrocarbon chain all over again. But look very carefully. There's also an OH group that is listed. If you look at cortisone, which is a hormone, well, you see something completely different again. You see some ring systems. You see these rings are fused together into this very cholesterol-looking molecule, which basically is cholesterol, by the way, just modified functional groups. But on this structure, you see some double bond O's, which are kind of like ketones, and you see some CH3 methyl groups, and you see an OH group, an alcohol group that's a functional group here, and you see another OH group. So we start to see more and more polarity in some of these. But cortisone, like cholesterol, is classified as a lipid. And then finally we have this PGE molecule. We'll talk about a PGE molecule a little bit later on in the module, talk about what it is and what's its purpose, but PGE molecules have something very common as well. And we see this ring structure with an OH group, a double bond O group, so we see some polarity on this end, and then we see again some long hydrocarbon tails, but we have OH groups again, and we have a carboxylic acid group again. So again, there's no rhyme or reason. All of these do have something very in common, though, and that is they are fat soluble, or that they are organic in nature. They do not want to dissolve in water. Now, you'll probably say right off the bat, well, vitamins, there's water soluble vitamins and there's fat soluble vitamins, isn't there? And the answer is yes, that is true. So we have a very gray line with lipids, and again, that is some of the problems that we see with this family of molecules. However, what we will do in this module is that we will pick out one group at a time of lipids. So for instance, we will take a look at the PGE molecules, and all the PGE molecules will have something in common that we can talk about. And then we can modify that slightly to give us new PGE molecules. But PGE as a whole will be classified as a lipid. We can do the same thing with a fat, like down here at the bottom. We can take a look at these types of molecules, associate them with very common functional groups that we see, and then once we do that, we understand that they are part of a larger family known as lipids. So stay tuned, buckle your seatbelt, because lipids is going to be a very bumpy ride. But I will say that the reactions of lipids are very few and in between. So we're just looking at structures, we're just looking at identification, and that's really it, people. That's all that we will be doing in this module. So again, it's a blend of nutrition, it's a little blend of chemistry, it's going to be a little blend of biology, and it's going to be a little bit of the Food Network channel all wrapped up into one. So stay tuned. I know that you're going to enjoy it.